We are fc42, and this is our D2 presentation for the CS6440 team project. Our project is the Opioid Crisis Management Dashboard. We were asked just to list our team players and our mentor advisors, so we'll slide through this very quickly and move right to our design. The overall design consists of three major components: user interface, which Nick will discuss in detail later in this presentation, the data gathering process, or the data update process, and the data store. The data update is responsible for periodically collecting data from external resources. Initially, this will be the FHIR server. In the future, this could be expanded to be any relevant data source. It will be written in Python, and it will be written on top of the Python FHIR client library. The data store is where we're going to provide our basic information storage. It will be Python on top of Redis. Initially, we see three containers for our deployment, indicated by our darker colored boxes on this graphic. Horizontally, they each can be scaled such that if we add more than one FHIR server, that'll be a container per FHIR server or for data source. And we see that there's a possibility of scaling out the data store into more of a distributed or ring-based database. And now Yu's going to talk about the research that we've done.
Based on our research, we decided to focus on three data types that are used by CDC for drug surveillance, which are prescriptions, disorder events, and overdose hospitalization or ER visits. Here are a few snapshots showing the FHIR resources that provide such information with their key attributes. They also cross-reference with the patient records so that we can obtain a demographic view of the data. These resources are confirmed with our external mentors. Next, we identified the opioid-specific code used in the selected FHIR resources. The results are summarized in this table. We'll use this collection for our early implementation. We'll focus on the set of code from our external mentors once available and supplement it with our collection when needed.
For our user experience design, we decided to create a persona that would be a typical user of the system. So as you can see here, we have Mary Catherine, who's 37, has experience in nursing and public health. She lives and works in Texas at a hospital, where she is senior manager of their prescription compliance program for opioids. She makes a pretty decent annual salary as well. Her motivation is that someone close to her was severely negatively impacted by an opioid overdose, and she wants to do everything in her power to make sure that doesn't happen again. She's also relatively technical. So as you stated before, there's a few lenses that we want to look at through the data. So you can see here between age, location, gender, and time, we want to cross-reference that with things like the ARCs, NORM and SNOMED substance products, the ICD-10 and SNOMED disorders, and the results of lyonic drug screens. So we have different representations between line graphs, geographical representations, and bar graphs that users can be presented with when they select different filters and criteria to show. For our user interface, we started off with making a typical username and password login. This is the screen the user will be presented with when they first log in. So as you can see here, there's facets on the left-hand column where you can select different disorders, different substances that you want to filter on, or the lyonic screening. And then at the top row, they can select filters between age, gender, location, and time. This is a representation of the ICD-10 code actually being expanded out. This is a representation when users actually select different ICD-10 codes and they select age and gender to filter on. So as you can see here, we have a bar graph for the gender and a line graph for the age. And this is a representation of time. So if users select ICD-10 codes and ARCs, NORM, drugs, and then they want to filter on a time variable, this is a line graph that they can see. So in conclusion, this is our designs for the Opioid Crisis Management Dashboard. Thank you.
Completed tasks like UI mockup and use case analysis have been added to the Gantt chart. While the remaining schedule remains the same, a new Jenkins test task has been added for deliverable 3. Our next steps focuses on development work, which includes, of course, a Jenkins test, work prioritization and allocation, as well as a review of our mockups that Nick has completed.